This is the Astronomy of Stonehenge, well, some of it, because the topic is enormous and I could keep you here for a couple of days if you weren't allowed to escape. And my background is physics and astronomy, and for 6 years I worked for English Heritage at Stonehenge, which allowed me to abuse my staff privileges and carry out some observations that wouldn't ordinarily be possible. Now, most people who start thinking about the astronomy of Stonehenge begin by drawing lines on a plan, on a map. And there's one of my first attempts, an orthographic projection, to allow me to work out the azimuths for the key points of the year, the summer solstice, winter solstice, and the lunar standstills. But really, you've got to pay more attention to the landscape and the shapes of the stones and not just draw lines on a map. Now, the astronomy of Stonehenge is quite controversial, and for the last 60 years or so, the rise of a new discipline called archaeoastronomy has taken off. And this is what I am. I'm an archaeoastronomer. And archaeoastronomy, as Ed Krupp from the Griffith Observatory once remarked, is a word with too many vowels. And archaeoastronomers do not go around digging up old telescopes. We do not do that. We're interested in humanity's relationship with the sky, going all the way back through our existence. But why do we think Stonehenge has got any astronomy at all? Anyway, to us it seems fairly obvious. Thousands of people gather there in June to watch the summer solstice sunrise. But prior to about 60, 70 years ago, it wasn't so obvious. So perhaps the best place to start is with this quote from Diodorus Siculus from around 2,000 years ago, which is arguably about Stonehenge. And he quotes Hecataeus of Abdera, who says, opposite the land of the Gaulish Celts, there's an island inhabited by the Hyperboreans, the ultimate northerners, and that on that island there's a magnificent precinct sacred to Apollo, the sun god, and a notable spherical temple. I translate that as Temple of the Spheres. It seems to make more sense to me. And it's said that in this island the moon appears very near to the earth, and the god visits the island once in the course of 19 years, a very lunar number. Blah, 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 and on he goes. So that's 2,000 years ago, and then nothing. Arguably that's about Stonehenge, might be about Carnish, but that's possibly the earliest reference to Stonehenge. And as I say, nothing from then until really the 18th century, when Dr. John Smith, the renowned inoculator of the smallpox, in an extremely catchily titled book, says the apex of stone number 1, that's the heel stone, the isolated standing stone away from the centre of the circle, points directly to the place of the solstitial sunrise. And he says that in 1771, gives us the idea that the heel stone is the marker, and he's completely wrong. He'd pinched that idea off William Stukeley, who 30 years earlier said it's the avenue, the ceremonial avenue that approaches Stonehenge from the northeast, that's the main axis of the monument, whereabouts the sun rises when the days are longest. Now, at the time when Stukeley came up with this, there had been a fair on Stonehenge Down going all the way back into the Middle Ages, but that was held on traditional Midsummer's Day, June the 24th. And it's quite remarkable that William actually came to this conclusion, because in 1740 we were still on the Julian calendar, which means that solstice wasn't on June the 24th or thereabouts. It was actually on June the 10th. So William could not have gone to the fair and just looked out at dawn and seen the sunrise and realised what was going on. He had to understand the astronomy of it to come up with this conclusion, because on June the 24th the sun would have risen far to the right of the heel stone. So well done, William Stukeley, for coming to this realisation, and not so well done to John Smith for pinching William's ideas and getting it wrong. So it's all about the summer solstice sunrise, isn't it? Typically anywhere from 20,000 to 40,000 people gather there to spend the night waiting for the sunrise over the Heelstone. And quite often it's rainy or foggy or misty or horizontal hail. It's Britain in the summertime after all. And it's quite difficult to get the actual photograph of sunrise because of all these people in the way. But I used to work for English Heritage, and abusing my staff privileges for a number of years, I used to go into the centre of the stone circle and stand exactly on the axis and look out down the line of the avenue to see if I could capture summer solstice sunrise over the Heelstone. And this next video will show you what I saw. You can just make the sun out rising from the right hand side of the tip of the Heelstone and heading off towards the top right. Wonderful mist across the landscape. Nobody else there, it's just me. Took me 14 years to get that shot, but it was well worth it. But if we take a closer look at that, we can see that there's the true horizon, and there's the sun as it appears out of the right-hand side of the tip of the Heelstone. And this isn't what the people who built Stonehenge would have seen, for two reasons. The first reason is that whole line of trees on the horizon wasn't there 4,500 years ago. It's a bare plain. And that line of trees, which is only about 50 years old or so, offsets the position of the first gleam of sunrise to the right. And once upon a time, 100 years ago, when the military were carrying out some early aircraft testing on Larkhill Down, they built a whole series of aircraft sheds across that horizon. And the private owner of the site at the time, a man called Edmund Antrobus, insisted that they leave a gap between these aircraft sheds so that it didn't obscure the rays of sunrise as they came down towards Stonehenge at the solstice. And the military were quite accommodating, and they left what became known as the Larkhill Sun Gap between their aircraft sheds. Sadly, in the intervening 100 years or so, they've forgotten about that, and all these scrubby trees have grown up, obscuring the first gleam and offsetting sunrise. And the second reason that it doesn't work the same today as back when Stonehenge was built is because of the change in the tilt of the Earth's rotational axis. This is the change in the obliquity of the ecliptic, not precession of the equinoxes, that's a different effect. This is the tilt of the Earth, not the directionality of the rotational axis. And the tilt of the Earth was 24 degrees when Stonehenge was built. It's 23.5 degrees today. So if you were to go back to when Stonehenge was built and remove those trees on the horizon, you would see the sun rising to the left of the tip of the Heelstone, not where it does today. So that's why it doesn't work in our era, exactly. But you could ask the question, why are we standing in the centre looking outwards, instead of standing next to the Heelstone and looking through the monument? A chap called Professor Terence Meaden has got it right. He suggests that it's the shadow play that's important at summer solstice sunrise, and this photograph is taken 15 minutes after sunrise on June the 24th, a few years ago, and the tip of that shadow is hitting the bottom of one of the entrance stones to the monument. But if you were able to go back 15 minutes and 4,500 years, you'd see that very strong shadow running up the slope and going through the centre of that middle gap, which is a deliberate entranceway left by the builders. The spacing of that gap is wider than all of the spacings for the other stones in the Sarsen circle. It's a deliberate entranceway, and the tip of that shadow runs up that slope and lands exactly on the centre of the altar stone. So Terry suggests that this shadow represents the symbolic fertilization of the earth goddess, represented by the circular Stonehenge with the inner horseshoe of trilithons, the big set of doorways, and that this is the earth goddess, and the sky father, the sun, at the height of his power on June the 21st, is in marriage with her and fertilising her. And it's an interesting idea because 9 months later on, of course, it's vernal equinox and the Earth springs back into life. So, the shadow play is important. So there's the primary summer solstice sunrise direction. Now to summarise it, the heel stone's the summer sunrise marker? No, it isn't. It's offset to the east of the primary axis. It's the avenue that aligns with the summer solstice sunrise. But the key point is, look through Stonehenge, not out from the centre. Of course, we've all changed our minds these days as archaeologists, and it's all about the winter solstice sunset, isn't it? And this idea is about 100 years old or so, and it suggests, in conjunction with evidence we've got from laser scanning, which shows that the stones on the northeast face of the monument are the best quality, the finest tooled and the most solid, that they frame the setting sun at winter solstice. And of course these days, English Heritage, with its interpretation officers, has decided that 900 tonnes of rock in a field with a very clear axis of symmetry isn't enough to point this out to people, so they've installed a massive bronze 10-tonne arrow in the line of the old closed road, and one end's labelled Summer Solstice Sunrise and the other end is labelled Winter Solstice Sunset, so you always know where to stand. So I thought, if I go out into the landscape, out towards Lark Hill, and look back southwesterly towards Stonehenge, I should be able to see the winter solstice sunset setting plop into the centre of the stones. And a few years ago, I decided to give that a go. And here's a time lapse to show the effect. Plop exactly into the centre. And here's a close-up. Same spot, same day, just with a telephoto lens. Wonderful. Except it's not quite right. That last gleam of the sun is appearing in a gap between two stones of the outer circle, which are the wrong pair. It should be appearing in the gap to the left of that tallest stone with the point on top. And the reason it doesn't work is because it's the same effect, that change in the obliquity of the ecliptic. So you've got to factor this in all the time. So there's the direction of the winter solstice sunset. The horizon is practically level in both the key directions. It's very low, only 1/2 degree in altitude. So these directions are reciprocal. The winter solstice sunset is opposite the summer solstice sunrise. The avenue aligns with it, and the last gleam falls between the uprights of the tallest trilithon, as seen from the centre line of the avenue, when obliquity was 24 degrees, and that's when Stonehenge was built. So we've defined the primary solar axis. There we go. Summer in one direction, winter sunset in the other. What about the moon? Remember that quote from Diodorus? The moon appears very near to the earth and the god visits the island once every 19 years. In the 1960s, two people independently, Professor Gerald Hawkins, astronomer in the USA, and CA Peter Newham, a retired gas board engineer from the northeast of England, both came up with the same idea. And that was that the long sides of the station stone rectangle had a lunar aspect. Now these stones, originally 4 and now we only have 2 remaining, form a rectangle that neatly encompasses the entire outer sarsen circle with clear sight lines from one side to the other. And they both suggested that towards the northwest it's the northernmost moonset that can ever happen, and towards the southeast it's the southernmost moonrise that can ever happen. And it's interesting that at the latitude of Stonehenge, the angle between those extremes of the moon and the extremest possible range of the sun, summer sunrise to winter sunset, form a right angle. So you can have a station stone rectangle that encodes the sun and the moon in one structure. And that doesn't work if you go 30 miles or so north or south, you get an acute angle or an obtuse angle instead. So the rectangle works at Stonehenge. In 2006 I thought I'll take some friends with me and stand in the North Barrow, which is the top right corner of that rectangle as we're looking at it here, and I'll look towards the standing stone, the station stone, that should point to the southernmost moonrise, and sure enough, every 18.61 years the moon rises over this chap who wouldn't get out the way. But there's the station stone, there's the true horizon, and that's the rising path of the moon, and it appears to work. Now, of course, that's 2006, and we are in the 2 years of the major standstill in last year in 2024, this year in 2025. And in May 24, I went into Stonehenge at night with a team from Bournemouth University to attempt to record the setting crescent northernmost moon. And it happened to be the evening where we had that massive auroral display all over British Isles. The most astonishing auroral display. So I had my camera set up taking a shot every few seconds of the setting moon, while overhead there's this fantastic display of northern lights. And there is the track of the moon. That white illuminated stone is the station stone, and there's a close-up, and you can see that track of the moon is heading down towards the horizon, and if you factor in the change in obliquity, that would have been a degree further to the right from our point of view, further out to the north, and it would intersect exactly with the station stone. So it looks very likely that Gerald Hawkins and Peter Newham's idea has got some merit. Now, Peter also had a second idea, and this was about the northernmost moon rise, which is in the northeast. And this is the winter rising moon, nearest winter solstice. And he pointed out that there's a series of post holes across the northeast causeway of the monument, across the earth bank and ditch that surrounds Stonehenge. And he thought they might have had a lunar function as well. And in this diagram, you can see the station stone rectangle marked stones 91 through to 94. And we're oriented with the heel stone uppermost, pointed out. And just to the left of the heel stone are 4 large timber post pits that were uncovered in excavations. And they're unfortunately known as the A-holes, but we're kind of stuck with that name. And what Peter is suggesting is that in that area, we've got a countdown to the northernmost winter moonrise every 18.61 years. And he suggests that the heel stone marks the midpoint of the swing of the moon in the winter. Sometimes it'll rise to the right of it, and sometimes it'll rise to the left of it, and that the A-holes, sorry about the name, are a countdown year by year. So if you're watching at one winter and you notice that the moon is rising over the heel stone, and the subsequent year it rises to the left of the heel stone, and then the year after that to the left of that position, and then to the left of that position, and then to the left of that position, you've got a 5, 4, 3, 2, 1, 0 countdown to the position of the northernmost winter moonrise in the lunar standstill. Now, the moon is very, very difficult to mark with markers like this because its declination changes so rapidly. It goes around the sky 13 times faster than the sun, so it is difficult to be precise, and it's very unlikely to get the moon rising in a visible phase over a clear, cloud-free horizon exactly at its maximum declination. So 4126 isn't precisely correct, but it's very, very close. And it's certainly possible that this is a 5, 4, 3, 2, 1, 0 countdown to this key event. So if we summarise this, the primary axis of Stonehenge is solar, and the primary axis of the earthwork with these post holes in the northeast causeway entrance is lunar, a lunar solely monument. Now back to the sun. What about the other components of the summer solstice and the winter solstice? What about the winter solstice sunrise and the summer solstice sunset? Introducing the notch. If you stand on the visitor path to the west of Stonehenge and you look through the pair of stones of the outer circle, you will see that there is a notch worked in the edge of one of the great big upright that supports one of the trilithons in the centre. And a close-up through that notch shows you that the open side of it is closed off by the edge of the stone that's also the upright of a trilithon on the far side of the circle. And that's a very tightly constrained sightline indeed, to a position over Coneybury Hill in the southeast. And if you look in that inset in the bottom right, you can see that electricity pylon that's there. It's a very useful marker, not Neolithic, but remember it. We look at that as a plan. We're standing at the bottom on the visitor path, looking through that set of three, through the notch in the side of stone 58, across the centre of the circle past the edge of stone 53, and then off to the southeast to the winter solstice sunrise. And in 2012 we were really lucky in that we got a totally clear horizon, and there is the winter solstice sunrise with the sun tangent on the horizon, and there's that electricity pylon. But we've got to factor in this change in obliquity again. So if we do that, we realise that 4,500 years ago the winter solstice sunrise was actually a degree further round to the south. And that's where it would have been. It's the sun, miss a sun, and then the sun. That paler faded one is the sun when Stonehenge was built. If we take that image and position and we superimpose it on our earlier close-up through the notch, you can see it's targeted precisely on that fully risen orb of the sun at winter solstice when Stonehenge was built. And this is discovered by Gordon Freeman, a professor at University of Alberta in Canada, published in a couple of books in the 2000s, the early 2000s, and he actually visited the site and spent time there looking through the monument and paying attention to the shapes of the stones and the shape of the horizon. So well done, Gordon. This hadn't been noticed before. And so here's a nice photograph of that view at the winter solstice from a little further away from the monument. And we're a few minutes after the actual moment of dawn for this shot, because you've got to wait for the sun to rise to reach that azimuth in our era and shine through the notch. And I always make a point of turning round and looking the other direction when we've got lighting effects like this to see what might be visible. And in the opposite direction you have these huge blocks of shadow that run out across the landscape with a beautiful beam of yellow sunlight framed between them, shining through the notch, and by pure fluke and coincidence, and it cannot be anything other than that, after 262 miles, that beam of sunlight goes exactly down the passageway at the passage tomb of Newgrange in the Bruneboyne in Ireland. And sometimes I give this talk to Earth Mysteries groups, and they get extremely excited about this. But are we talking about long distance surveying over that sort of distance, including a huge body of water and a span of time between 3100 BC for Newgrange and 2500 BC for Stonehenge? I think that's unlikely, but it's a lovely coincidence that the universe sometimes throws at you when you're paying attention to this stuff. So there's the winter solstice sunrise direction through that notch. And that sight line runs exactly along the midline of a very specific and important stone in the centre, more of which later. Now, of course, the reverse direction to the winter solstice sunrise is the summer solstice sunset. So we should be able to stand on the southeast side of the monument and look back along that sight line through the notch to watch the summer sunset. And in this particular spot, you are obscured from seeing the notch clearly because of the collapsed remains of the tallest trilithon. So that's the lintel lying on its side, and that stubby block that's coming out from the base of the sharp edge stone is the top of the upright that has now fallen and broken in two. So you have to be slightly off axis to be able to observe this in our era. But 4,500 years ago, a clear sight line. So does the sun set into that notch? Of course it does. There it is. And it genuinely was that colour. The military had set Solitary Plain training area on fire, as they do every year, accidentally, and the smoke was giving us this wonderfully pink sun. So there is that sun setting into that notch. And if I was standing precisely on that sight line 4,500 years ago, it works exactly. So there's the summer solstice sunset direction, looking backwards along that sight line through the same notch. And again, that sight line runs along the midline of that very specific and important stone. So there's the secondary solstice axis, winter sunrise to summer sunset. Fabulous. And those two solstice lines intersect in the centre of Stonehenge at an angle of 80 degrees, give or take. That's round numbers. And the reason it does is because summer sunrise to winter sunrise in the era of Stonehenge's construction was 80 degrees. And that's why that's that angle. And that intersection point is exactly over the centre of the altar stone. Interesting. Is there anything else with an 80 degreeness to it found in the Stonehenge landscape? Well, yes. There is the fabulous treasure of bush barrow, uncovered in 1808 from a round barrow from the Bronze Age that's about half a mile or so southwest of Stonehenge, and the grave of somebody who's come to be known as the Stonehenge chieftain or the Stonehenge shaman, but that's a very overloaded word. And this is an exquisite piece of art. It is roughly 15 centimetres side to side and about 20 centimetres top to bottom, and the acute angle of that lozenge, the bush barrow lozenge, is 80 degrees, the same angle as between the summer sunrise and the winter sunrise and the sets when Stonehenge was built. But this post-dates Stonehenge by a good 800 years. So it suggests that the people, perhaps, who were being buried in this landscape, who were not the builders of Stonehenge, still appreciated these key directions. And you can take that lozenge and overlay it in the centre of Stonehenge, and it works perfectly. It encodes the geometry necessary for the sun. So, if you've got a handle on the movements of the sun and you've got a handle on the movements of the moon through its 18.61 year cycle, conceivably you could keep track of eclipses. And that's a montage of the 2015 vernal equinox eclipse over Stonehenge of mine. Very nice, slightly cloudy, but it did work. And in the 1960s, two people, it's that same Gerald Hawkins again, and a little later Fred Hoyle, both came up with the idea that the 56 Aubrey holes that surround Stonehenge and are very early, probably 5,000 years old, before the big rocks were put up in the middle. Gerald suggested that they could be used to keep track of the sun and the moon in the sky, along with the crossing points, the nodes, and therefore track eclipses. And Fred Hoyle refined Gerald's recipe a few years later, and this is the one I'm going to talk about. You have to imagine that Stonehenge, the rocks, represents the earth, and that the 56 Aubrey holes in a ring around the outside represent the sky, divided up into 56 sections. And you're going to need some markers for the sun, the moon, and the crossing points. You're going to need a sun marker, which you're going to move 2 holes every 13 days, which means it will go round that circle once in 364 days, which is very close to the length of a year. And you're going to need a marker for the moon, which is going to go round the holes at a rate of 2 holes a day. So it's going to be moved once around the circle in 28 days, which is very close to the 27.3 days of the moon's period. And you're going to need markers for the crossing points, the ascending and descending nodes, and these are always opposite each other in the circle, and they move in the opposite sense, 3 holes a year, which means that they go round once every 18.66 years, which is extremely close to the 18.61 years regression of the lunar nodes cycle. Now, obviously there are inaccuracies in this, but they can be corrected through careful observation. We won't go into them now, but they can be. And for the nodes, it's important to realise that you don't just get eclipses when the sun and moon are both at the node or at opposite nodes to each other. You can get eclipses when the sun and the moon are near a node. And it turns out that the range that's important is one Aubrey hole either side of your node marker. That's the zone of eclipse possibility. So here's the setup of the March 20th, 2015 solar eclipse. Sun and the moon markers are both in our Aubrey hole together in that zone of eclipse. The photo shows the eclipse in the top left, and some people who came to visit it in wonderful colander tinfoil helmets to watch it from the site. And I thought, you might not have tried to operate an Aubrey hole eclipse predictor yourself, so here's a worked example. Start with that situation. And the next day we move the moon 2 holes. It's going to go around once every 28. So that's the 21st of March, 22nd, 23rd, 24th, 25th, 26th, 27th. It's time to move the sun marker. It's going 2 holes every 13 days. So let's move it 1 hole after 6 days and the second hole after another 7 days and keep track of that. It's quite tricky. You can find yourself at 6s and 7s. I wonder where that phrase comes from. So we'll carry on. 28th, we're moving the moon marker 2 holes again. 29th, 30th, 31st, April the 1st, April the 2nd, and it's time to move the sun again. 1 more hole. Carry on, the 3rd, the 4th. Now this is a prediction. This says that at the full moon, with the sun and the moon opposite each other in the sky, and both within a zone of eclipse, we should have a lunar eclipse. And obviously this is nonsense and it doesn't work at all, except it isn't. Okay, this is 2 weeks after a solar eclipse. You're on a fairly decent bet that you're going to get a lunar eclipse afterwards, but it shows that over short time periods this does work, and with the corrections you could conceivably keep track over longer periods. So it does kind of work as a recipe, but the archaeologists at the time absolutely hated the idea. And Richard Atkinson, who was the leading Stonehenge archaeologist in the 1950s, 60s and 70s, called the people who built Stonehenge howling barbarians and utterly rejected this idea that they could keep track of the sun and the moon with such accuracy and carry out these observations to be able to predict eclipses. Completely failing to take into account that humans have been looking at the sky ever since we've looked at anything. And we've been quite intelligent for quite a long time. But he said, if 56 was a significant number for eclipses in the ancient world, we'd find evidence of it elsewhere. The implication being that we don't. Now, the trouble with this is that we do have evidence that people are tracking the movements and the numbers, crucially, of the sun and the moon in the archaeological evidence. And one of the earliest bone records that we've got of somebody recording the phases of the moon, 29 carvings showing a crescent to a circle to the opposite crescent, is on a bone from 35,000 years ago found in a cave in France. So humans have been looking at this stuff for a very long time. Subsequent to Atkinson's rejection, it transpires that this isn't a new realization that Gerald came up with, because the Pythagoreans knew this. This is Plutarch, 2nd century AD. They believe that Typhon is a demonic power and the 56-sided polygon belongs to Typhon. And there are some who give the name Typhon to the shadow of the earth into which they believe the moon falls and so suffers eclipse. Eclipse 56. And the shadow of the earth. This is Plutarch, writing in the 2nd century AD, and he's quoting Eudoxus from the 4th century BC, who's talking about the Pythagoreans. We might have known about this for a very long time. It's just that archaeologists and astronomers don't tend to read Plutarch very often. So there is some evidence. And there's a photograph of the total lunar eclipse in September 2015. And just to give you an idea, that's Typhon. That's the shadow of the earth. But is this the only 56 that we find associated with the sun and the moon? Well, no. There's Alustana in Sweden, the 56 stone plus 3 stones for a prow, mast and stone boat that's located on the coast, looking out, oriented towards the winter solstice sunrise and back to the summer solstice sunset, constructed at the precise latitude where those directions and the directions of the summer sunset to winter sunrise and summer sunrise to winter sunset make a right angle, as opposed to the 80 degrees that it is at Stonehenge. It's interesting. We've been paying attention to this for a long time. But one more thing. That altar stone inside Stonehenge, we've always thought for the last 100 years that it was Welsh. It probably came from Milford Haven and was picked up en route from the Preseli Hills when the bluestones were being transported from there, probably 5,000 years ago, to be installed at Stonehenge. But research in the last sort of 12 months, in 2024 it was announced, the altar stone's not from Wales at all. It's from Scotland. It's from a section of northeast Scotland called the Orcadian Basin. Not necessarily the Orkney Isles, but the geological formation of the northeast of Scotland, where we know there is a society that is obsessed with tracking the movements of the sun and the moon. We've got examples in the Hebrides of Callanish, we've got recumbent stone circles in northeast Scotland, we've got the Ness of Brodgar, ancient temple site with the ring of Brodgar at one end and the stones of Stennis at the other, and Maze How in Orkney oriented to the winter solstice. This is really interesting. This society seems to have taken a stone from their part of the world and dragged it 500 miles to Stonehenge. Why would you do that? The stone now sits in the centre of Stonehenge at the intersection point of the two solar axes of the later large Sarsen phase of the monument. But has it always been at that spot? Was it potentially somewhere else on the site earlier? In the 50s, Atkinson re-excavated a whole series of pits that had been dug by earlier archaeologists in the start of the 20th century because he wanted to see if they'd got all the way down to the bedrock, and in some cases they hadn't. And at one spot, that spot indicated, on that primary axis, he discovered at the bottom of the earlier archaeological pit, when he bottomed it out further, that there was a stone hole. And in that stone hole had been deliberately deposited a Group 1 Cornish Neolithic stone axe, and that's of a type that dates to around about 3000 BC. And that intrigued me, and I wondered if perhaps, maybe the altar stone was once upright and in this stone hole, and that subsequently has been moved to where it is now. But to kind of apologise for taking it down, the people who built the big stone phase at Stonehenge put an axe in the stone hole as an offering. Okay, that's a bit of a speculative flight of fancy, but what happens if you do put the altar stone upright in that hole? If you put it there, what do you get? Well, the line between that position and the station stone that my setting crescent moon with the aurora overhead was setting into, that line is exactly parallel to that secondary solstice axis that now runs along the long axis of the, I suggest, relocated altar stone that was moved when the second large stone phase of Stonehenge was built around about 2500 BC because it was in the way for erecting the tallest trilithon. And if it was there, that's all you need to do the whole sky at Stonehenge 5,000 years ago. You need a station stone rectangle for the primary solar axis and the lunar standstills, and you need an upright altar stone at that position marked in green to give you that secondary solstice axis. Are those the founding stones of Stonehenge? 5 stones with possibly the heel stone there as well. That's the whole sky, bar one thing. What about the northernmost moonrise? It turns out if you twist that upright altar stone so that it's not perpendicular to that primary axis, if you twist it 80 degrees so that its flat face lies along that secondary axis, then the perpendicular to that is the northernmost major moonrise, just to the left of those A-holes that are just west of the heel stone. That is an incredibly elegant way to catch all of the sun and the moon's extremes with basically 5 stones, a station stone rectangle and an altar stone. 5 local sarsens if you include the heel stone, and 1 Scottish stone is all you need. And later on, the large stone face of Stonehenge is just a more elaborate version of that skying capture. And that's all you need for that. It's a beautifully elegant way of catching what is ultimately intangible, which is the sky, and bringing it down to the ground and making it tangible and demonstrating to everybody that ever sees this that the people who put it together understood the movements of the sun and the moon. It's a lasting testimonial to their observational skills and their engineering prowess. Are these people howling barbarians? It's not just about the stones in the centre. It's about the landscape that surrounds it, it's about the long distance views, and it's about elegant subtleties. And it encompasses the entirety of the British Isles. Everywhere is special and sacred to these people. It's a songline landscape, and we've forgotten the words. Thank you very much indeed.